Good day, learners. We are now going to go to the next subsection in the concept that we are dealing with, topic 2, factorization. In this topic, we are dealing with the difference of two squares. Again, it is an examination type question, but it is something that you would have come across before. Now, I want you to consider the following. Let's say we have x minus y into x plus y. If for some reason I had to go and multiply this out, I would now go ahead and use the following method or the half moon method, doesn't make a difference. But if I multiply this out, x times x is x squared, minus y times x is minus xy, x times positive y is xy, and negative y multiplied by y gives me negative y squared. If I have to simplify this, the negative xy, the positive xy cancels off. I'm left with x squared minus y squared. On the same manner, guys, if I deal with c minus d into c plus d, I would multiply out, and you will notice that when I do this, I end up with the negative cd cancelling off with the positive cd, and I'm left with c squared minus d squared. This here, guys, is the difference of two squares. It is very easy to recognize it because, as the name suggests, it is the difference of two squares, meaning this square and that square are two things that I can find the square root of. The answer here always results in the difference of two squares. In order to factorize the difference of two squares, as the name suggests, we have to identify that is indeed two complete squares being subtracted. The first factor gets a positive sign and the next a negative sign. Sometimes it is necessary to start off by removing common factors. What I have done here, guys, is just a bit of theory. It will not make much sense to you, but let me explain what this exactly means. When I'm dealing with the difference of two squares, I'm moving from this side to that side, which means I am factorizing. This is my question, and that becomes my answer. I've highlighted this to show you that it is indeed multiplied out will give me this, factorized will give me that. X squared minus y squared is the difference of two squares. Now, in order to simplify this, let's go to an example and understand how it comes, or how it is easier with an example. Factorize the following expression: x squared minus y squared. Now, guys, I'm going to go a bit slow with this so you can understand what I actually mean. Question 1. Factorize. You would notice that I cannot remove common factor. The next thing that you would notice is there's two parts to this expression, separated by a negative sign. The moment that you see that, the first thing that should spark in your head is the difference of two squares. Now you're going to ask yourself the question, there's an x squared. Can I find the square root of x squared? There's a y squared. Can I find the square root of y squared? And you can. Guys, watch this. I'm asking you, what is the square root of x squared? And the square root of x squared, you know by now, is the same as x squared raised to the exponent a half. And this becomes x to the exponent 2 multiplied by half, which is 1. What is the square root of y squared? The square root of y squared will be worked out in a similar manner. I have here y squared, which is raised to the exponent a half. And how do I get this, guys? Remember, the square root of y squared means the y must be raised to the exponent a half. Yes, 2 times a half is 1, so this becomes y. Some of you might want to cancel off that with that. You're welcome to do so. Right? But I'm explaining this way so it will help me with more difficult examples. Now I have the square root of the first term, which is x. I have the square root of the second term, which is y. What I need to do here is I need to write down, let me just go back, I need to write down x, which is the square root of x squared. I need to write down y, which is the square root of y. I repeat the bracket. There's a x, there's a y. And all that happens now, guys, is I put one as being positive, I put the other one as being negative. And my answer is x plus y into x minus y. I'll explain this as we go further into the examples, but this is coming from the original question that I had. Let's go further. What happens if I ask you to factorize x squared minus 9? The first thing that you notice, again, there's two terms separated by a negative sign, which means there's a good likelihood that this is the difference of two squares. I cannot remove common factor. Now, my question to you is, how do I simplify this? I need to find the square root of the first portion, the square root of the second portion. What is the square root of x squared? By now, guys, you know the square root of x squared is x. What is the square root of 9? The square root of 9 is equal to 3. Do not worry about the plus minus for now. It's equal to 3. The square root of the first part, the square root of the second part. I now go ahead and put down my bracket. The square root of x squared is x. The square root of 9 is equal to 3. Whatever I have in this bracket, I repeat that bracket. I put one sign as being positive, I put the other sign as being negative, and that is my answer. How's that, guys? Are you getting the idea? What about 2x squared minus 32? The first thing that I notice over here is I have a 2, I have a 32, which means I can remove common factor. If I remove common factor, which is a 2, I'm left with x squared minus 16. Now, if I'm dealing with x squared minus 16, again, I need to be able to factorize this. If I'm going to factorize this, guys, how do I do it? I go ahead and say, what is the square root of x squared? The square root of x squared is equal to x. What is the square root of 16? The square root of 16 is equal to 4. And yes, guys, I write down my x together with a 4. I repeat the bracket x together with a 4. And yes, I need to put a sign here and I need to put a sign here. One sign is positive, the other sign is negative. And that gives me the answer 2. Do not forget that this 2 is part of the solution. Many learners omit this 2. X squared minus 16 factorizes to x minus 4 into x plus 4. Brilliant. Let's go further, guys. I hope you are getting an understanding of what is going on over here. What about a question like this? X squared minus 4. Now, x squared minus 4 is a good example. If I look at this, guys, ask yourself the question, can you find the square root of x to the 4? Now remember, the square root of x to the 4 means that x to the 4 is raised to the exponent a half, and that becomes 4 times half, which is 2. What about the square root of 1? The square root of 1 is equal to 1, which means I use x squared and I use 1, which is in my bracket. Now, guys, to cut a long story short, it's x squared 1, and what do? I repeat it, x squared with 1. The sign I put here is a positive, the sign here I put is a negative, and that's exactly what I have here. Slightly inverted, but not a problem. Once I do this, before I even go to my next question, look at the brackets and ask yourself, can I not perhaps factorize the bracket any further? Look at this portion, x squared minus 1. X squared plus 1 I cannot factorize because this is not the difference. But x squared minus 1 I can. How do I do this, guys? I find out what is the square root of x squared? It's x. What is the square root of 1? Which is 1. So automatically now I have another two brackets here. And the two brackets become x1, x1. I put 1 as being positive and I put 1 as being negative. And this simplifies or factorizes to this. Guys, can you see that? This x plus 1 is already simplified. I cannot do much with that. But x squared minus 1 simplifies or factorizes to x minus 1 into x plus 1. Does not simplify, guys, it factorizes into. How's that? This is a typical examination type question. How about number 5? Number 5 takes us to something a bit more difficult, but guys, we will be able to work with it. 16x to the 8, 81y to the 8. Question: can I remove common factor? Highly unlikely. But watch what happens over here, guys. If I take the 16x to the 8, I want to know what is the square root of 16x to the 8. This is the same as the square root of 16 multiplied by the square root of x to the 8, which is the same now. The square root of 16 is 4. The square root of x to the 8, by now, guys, you can see I simply take this number, I divide it by 2, which means it becomes x to the 4. Very good. What about 81y to the 8? 81y to the 8. Again, I'm going to skip a step. The square root of 81 is 9. The square root of y to the 8 becomes y to the 4. And these are the two numbers I'm dealing with. 4x to the 4, 9y to the 4. And yes, guys, what do? I repeat. 4x to the 4, 9y to the 4. One becomes a negative, while the other one becomes a positive. It doesn't matter which one you do first. Some of you prefer putting this as positive, that as being negative. You're welcome to do so. Now, when you come to this step, double check your brackets. Ensure that you cannot factorize any further. If I look at this question, whoa, look at this. Obviously, this is fine. That's a positive. It's not the difference. This can be factorized further. But now, guys, you don't need to show all this working, because this is working that you need to do by yourself. Watch this. 4x to the 4. The square root of that is 2x squared. 9y to the 4. The square root of that is 3y squared. And of course, you put it as 2x squared, 3y squared, 2x squared, 3y squared. And if you look at this, guys, one is negative, one is positive, and obviously this you leave as so. I just went over it a bit, guys, but you can see the answer. You can look at this a bit further, guys. Understand it. Ask questions if you need to. This is a typical examination type question. Thank you, guys. We can now go to our activity. Take your time with this activity, guys. It's something that you want to work with. It's something that can be a bit confusing, but at the same time, guys, it's something that you can get marks on. Numbers 1 to 10, press pause. And let's go to the solutions. Again, guys, I'm not spending too much time on the answers. You can ask your lecturer in front of you. Number 1, pretty straightforward. Number 2, again, pretty straightforward. That's 3x. That's the 2. Repeat the bracket. One is negative, one is positive. This square root of this is 5x. Square root of this is 4y. Repeat. Change the signs. Number 4 is quite easy. Number 5, again, not a train smash. You will be able to answer that. Number 6, that becomes 11y. Square root of 81 is 9. One is negative, one is positive. Ensure that you cannot factorize the brackets any further. In this case, you can't. That is the answer. Number 7. Watch this, guys. 81x squared, square root is 9x. What about this? What is the square root of y squared over 49? What is the square root of that? The square root of that is the same as the square root of y squared over the square root of 49, which is equal to y over 7. Perfect. Number 8. Again, I chose to write over it. Sorry about that, guys. Number 8. Be careful with this one. Can you see I've included square brackets? just to be able to, these are the order of brackets that I'm using, guys. Right? There's my positive and there's my negative. 2x minus 1 all squared, the square root is 2x minus 1. Square root of 9y squared is 3y. For this one, guys, please, I would recommend that your lecturer does it one more time with you, or similar examples. Number 9, quite straightforward. Number 10, look at number 10, guys. I remove common factor. I'm left with p squared minus q squared. This bracket I can't simplify. It becomes p minus q into p plus q. And with that, guys, I thank you and good luck.